Bismillahirrahmanirrahim. Assalamu alaikum dear students. You are watching Study with Sheraz, and in today's lecture we are going to talk about the instrumentation of the spectroscopy. If we talk about the instrumentation, 5 common parts of the instrumentation of spectroscopy are recognized, and these components are found in each and every type of the spectroscopy. Here is a schematic diagram which is showing the important components of instrumentation of spectroscopy. But when we move toward the specific types of spectroscopies like the UV visible, IR and NMR, certain variations are found because each and every type of the spectroscopy is related with a different type of the molecular transition, and different mechanisms are involved in the spectroscopic measurements. The 5 important components of the instrumentation of spectroscopy are: the first one is the source of electromagnetic radiations. That's represented here, maybe a bulb or an other type of the instrument that is electrically heated. Bulb are mostly used, or some kinds of the LEDs are used, that or some kind of the discharge tubes are acting as the source in different types of the spectroscopies like the deuterium lamp, or some other use the laser lamps. So different types of the sources are used in different types of the spectroscopies. Different wavelengths are produced from the source. The second most important component of the instrumentation is the monochromator. As the word indicates, mono means one, and chroma word comes from the color, and it's used for the wavelengths. So monochromatic light is the light which is having radiations of the single wavelength, and in the spectroscopy it is desired that a very narrow range of the wavelengths should be used, because we cannot make any light perfectly monochromatic, because there are certain variations and differences in the wavelengths of radiations. So a monochromatic is a component of the instrumentation that produces a narrow beam of the radiations or a narrow range of the wavelengths. It may be a prism just like presented here, or some kinds of the filters are also used as the monochromator. The next component that is shown here is a slit. Basically, the prism produces the wavelengths of one or the narrow range of wavelengths, and the slit is a small plate having a narrow bore in the center that's used to produce a very narrow beam of radiation. It allows radiations only that are moving along a narrow path, and it blocks the radiations that are moving in the broad way. So it's used for the narrowing of the beam of radiations. The next component is the sample holder. It's mostly a quartz tube or cuvette that contains the sample or the compound of interest. So whenever the radiations pass through the sample holder, the sample or compound present inside the sample holder causes absorption of the radiation. So the next is a detector. So detector is a device which measures the intensity of transmitted radiation. Basically, whenever the light is moving away from the monochromator and it's going toward the sample holder, its intensity is the I0. I0 represents the intensity of incident radiation, and after passing through the sample, there happens a small decrease, so their intensity is represented by the I. So detector is a device which measures the intensity of transmitted radiation, and then it compares it with the intensity of the incident radiation to find out the absorbance. There are many types of the detectors that are used in the spectroscopy. Most of the time photomultiplied tubes are used as the detector, but some other kinds of detector are also available. And detector converts the transmitted radiation into the electrical signals. The next is the readout device. Basically, readout device is something that can hold the signal from the detector, amplifies it. So amplifier is a device that can amplify the signals, enhances the magnitude of signal, and then there is the recorder. Recorder is basically the component which reads that information and then converts it into some quantitative data. It may be a digital recorder that can give us certain numbers. It may be just like an instrument that can give us a spectrum or graph. So readout device contains the amplifier and the recorder. So these are the commonly found components, are the important components that are shown in the context of the instrumentation in a general sense. So some specific types of the instruments are used based upon their different variations. So different techniques use different types of the instrument, and keep in mind that all these components are found within one box, within one instrument. All these components are present. The names of that instrument also vary according to the variation. As you people are watching here, that I have written an equation. So this is basically the equation which can help to find out the value of absorbance. As you people see here, A is the log I naught over I. I is the intensity of incident radiations. So I is the intensity of transmitted radiation, and their ratio can give us value of the absorbance. So this is the way the recorder shows the absorbance. So here we talk about the different types of the instrument and their different variations. So first one is the spectrometer. It measures only intensity of the transmitted radiation and does not measure the absorbance. So this is a device that is aimed only at measuring the intensity of the transmitted radiation. It has nothing to do with the absorbance. So there is a system later in the device that can find out the difference between the intensity of the incident radiation and that of the transmitted radiation. Basically, it is, as the word indicates, spectrometer. So it is concerned with the spectrometry, and spectrometry is concerned with the quantitative measurements of the concentration of an light. Second one is the spectrograph. It's a spectrometer that uses photographic plate as the detector. As I have mentioned, there are various types of detector. It may be a photographic detector, it may be a photomultiplier tube, or anything else. So a spectrometer that uses photographic plate is called the spectrograph. The third one is the photometer. It uses filter to provide monochromatic light. As I have mentioned here, that monochromators are of different types. So basically the component is the wavelength selector. So wavelength selector can be a monochromator and wavelength selector can be a filter. So filter is a wavelength selector that uses the phenomena of absorbance for the selection of a specific type of the wavelength. So photometer uses filter to provide monochromatic light, and filter may be a thin film of colorimeter, a photometer that only works for visible vision. So it is the photometer that is specified for the visible region of the electromagnetic spectrum. And the last one is the spectrophotometer. The difference between spectrometer and spectrophotometer is very important. It uses monochromator as the wavelength selector. Monochromators are basically the component of the instrument that act as the wavelength selector. They are in the form of mostly optical instruments, just like the, you can say, prisms, and that use the phenomena of the dispersion or diffraction of light in order to get the specified wavelength. So difference between the filter and monochromator is that filter uses absorbance phenomena to get the specified wavelength, whereas the monochromator uses the dispersion phenomena or the diffraction in order to get the monochromatic light. And the spectrophotometer is an instrument that is mostly used for the qualitative analysis. So this was all about the instrumentation of spectroscopy. If you have any question related to this video, you can post your question in the comment section. We will meet in the next video. Up till then, Allah Hafiz.